So our topic tonight is electronic power steering testing and repair. So we're going to talk about kind of how these systems work, how they're set up. Um, really developed over the last probably 20 years or so, and really longer. They've been in a lot of production cars since even the 90s, even before that. So they've been around. They just haven't been as common as they really are today. And with ADAS and all these lane departure and automatic lane keeping assistance and stuff like that, that's really where the electronic power steering comes into play. And also, with electric vehicles on the rise, there's a lot more of those electronic power steering systems in those, just because it gets rid of that belt-driven pump, which is one of the main reasons that they do it. So when we talk about electronic power steering systems, there's a few components. There's not a ton of components in there that really to speak of. Your steering angle sensors, sometimes multiple steering angle sensors, top and bottom. Torque effort sensors, so the vehicle knows how much effort you're putting into the steering wheel. Sometimes they give haptic feedback as well on some cars. Yaw sensor, which also affects so the vehicle knows which way the vehicle is pointing. Electric pump could be used, or an electric steering rack where the motor is actually built onto the rack, or it can have a separate electric motor and like a power pack, they'd call it, up close to the top of the steering wheel. So, uh, like I said, early in the 90s, they really started using it on Acura NSX was one of the first, mainline, mainstream cars, I guess you could say. I don't know how mainstream it was. It was kind of pricey and kind of sporty car, but the reason they used an electric rack on that was almost out of necessity because it was their first mid-engine drive car. So the pump, of course, would have had to be in the back, and they would have had to run the lines underneath and up to the front, and they didn't want to do that. So they said, we're just going to put an electric power steering rack in the front, and that's just kind of how they did it. So as you can see, this is right from Honda, Acura. So it's supplied power. It's got an electric motor in there that moves the rack inside, left and right. So you see you got a little reduction gear there, and that's just how it moves it. Moves the rack left and right. So it's got a computer controller and needs to know the speed the vehicle's going, and it gets it off the automatic transmission in that case. Of course, the alternator supplies power. So yeah, it's got a steering sensor in there to know where it needs to turn and how much it needs to turn. But yeah, that's one of your earlier motor-driven designs. And if we think about how many inputs this needs, we're going to look at this a little bit later. I'm going to go look in Shopkey. And we're going to need a lot of inputs. And it needs a lot more inputs than you might think. And some things need to be coded, reflashed, reprogrammed, something like that, depending on what it is. So in this case, we have the electronic power system gear. And the power steering control module, torque sensor goes in there, position sensor with the motor and the motor position sensor, not just the steering wheel position sensor, but the motor itself has a position sensor. So it knows where so it knows where that is. We got ABS inputs, image processing module inputs, torque converter, transfer case, PCM, BCM, TCM, all these things. It needs certain inputs from everybody. So just kind of more complex than it might seem on the surface is what I'm trying to say. You definitely need a scan tool to help you with. So the steering angle sensor translates rotational motion to electronic signals. So that way the control module knows where the steering wheel is. It's usually keyed to the steering shaft. It's often located near the steering wheel, but it could also be located at the other end, down in the rack. It's usually inserted with the clock spring as well for the airbag. Oftentimes they're mounted and bolted together. And must be recalibrated after repairs. You need to tell the computer where zero is when you replace it, you repair it, or even just remove it and put it back. You need to recalibrate it. Torque effort sensor is going to be on the other end of the shaft in this case. So this is, I believe, this is on an Acadia, and the torque effort sensor is down the bottom, and it looks like it certainly also has a steering wheel position sensor in there as well. Now, some vehicles, like I said, could use an electric rack. itself. Sometimes the just the pump is electric. Sometimes the rack is electric. So in this case, this is an electric rack, and a lot of manufacturers are using this. Um, not just when I was looking to try and find the many different rack types that were out there, I was just looking through random different vehicles, and a lot of them use that similar system where they got the electric motor that turns a gear down here, and that's what moves the rack in and out. So it kind of looks like this. It's just kind of you can see the input there, and then it plugs in, and then you got a little belt in here, a little drive belt um, that drives off the motor here, and then it turns this gear, which is threaded on the inside, and you can actually see it a little bit better in this on this side of the picture. But where the rack is threaded, it turns and pushes it in and out depending on obviously if it moves clockwise or counterclockwise, it's going to push that gear inside or outside of the rack, depending on which way you need to go. Other vehicles don't use an electric rack. They just have just kind of it's pretty much just a manual rack, a manual rack from manual steering back in the day. And then they have a motor pack up on top. So this is out of a Kia, and it uses it. Nothing's serviceable in here either. You have to replace it all as an assembly, but it has the control module, the motor there, and the motor turns and assists with the steering wheel. Also useful for lane departure, right? Trying to keep the car in the lane. It'll steer it for you based on inputs from cameras and all that stuff. It'll steer it and put you back in your lane. It can even change lanes for you, some of these vehicles. So that's another useful aspect of having the electric power steering, other than not having not have to worry about the pump and the hydraulic lines and all that other stuff. So it increases fuel economy too, because we're not driving that pump. But they also use these, like I said, and it kind of looks like this. A picture I found on Wikipedia here, and there's your steering angle sensor up there, and then it comes down. You got a tilt and telescope column, and then it's got the little motor that's just basically attached to the shaft, and it runs the shaft. Now, another unique one I did find is 2014 era Q50s up through the 2020s, Infiniti Q50. It had electric power steering, and they wanted to not have a shaft connected between the steering wheel and the rack down the bottom, but wasn't very long lived because it wasn't very popular. It didn't really take off, but they also needed some way to mechanically couple them together in case of a failure. If you think about it, if I have no shaft connected and it's only run with an electric motor, if I have some sort of a failure in that electrical system, I'm not going to be able to steer the car, and that's kind of dangerous. So what they did is they have a clutch that's in here. So that's kind of what this number one is pointing to. It's a big clutch pack that it's not connected until it has a failure, and then it's connected. So it's interesting system of how they did it, I guess. But some of your newer vehicles don't have a steering shaft anymore, especially a lot of your newer EVs don't have a steering shaft at all either. It's just a steering wheel or the yoke, depending on what you want to call it. Cybertruck doesn't have a steering shaft, that sort of thing. It's just purely electric, and I guess the motor technology has come a long way since 2014 or so. So maybe they can get away with it now, and they're starting to use it more, and without having to have that mechanical failsafe in. All right, so let's go live. We're going to look at a few different things, a few different vehicles, and just some of the things you might need to do with it, and some of the information you might need. So first off, I'll go into this F-150. 2019 F-150. F-Series, there it is. Okay. So on these, actually, let me go into shop. We'll go backwards from what I was going to do. We'll go the other way. All right, so I just put in my steering box. There we go. And if we go in here, I think it's in with component operation. It should be with EPAS, which is the electronic power assist steering, not for the Raptor though. It's a gear assembly consisting of a PSCM, a motor, and a steering torque sensor, all of which are serviced as an assembly. So once again, you can't redo that. The inner and outer tie rods and the steering gear bellows boots are available separately for service. So you can change the tie rods if it gets in a wreck, but otherwise, internally, it needs to be replaced. Steering torque sensor is mounted near the input shaft of the EPAS gear and is used by the PSCM to determine how much force is being used to turn the steering wheel. The gear has one inner tie rod located at either end of the gear assembly, has one outer tie rod located at each end of the gear assembly, one bellows boot on each end of the gear assembly. So it's basically a regular rack, inner and outer tie rods, just has the power steering motor on it. So if we go into remove and replace here, there's a lot of steps in here, but it's basically, it looks just like your regular motor. I mean, your regular steering rack, right? So it's got the electric motor on. It's got a big heat shield on it. Power steering control module, a couple big bolts. There's your motor there. There's your motor. So this one uses that belt-driven system as well, where it goes, counterclockwise or clockwise and pushes the rack in or out with that. Right, installation is reverse to removal. However, if I go all the way down to the bottom here, oops, not quite that far on the bottom. That's for the tie rod. That's for the tie rods. I went too far. There we go. So when installing a new steering gear on this Ford, must be configured using vehicle as-built data or module configuration information retrieved earlier in this procedure. Connect the scan tool and follow the scan tool instructions. So you would be using a PMI procedure for that. And if you just to replace the rack, you have to do a PMI procedure on that. Let me go into here and go into steering here because it actually has all of the yeah, that's what I was looking for. Network message chart. So this is all the inputs that it needs in order for it to function. So if I have an issue in some other part of the vehicle, it might cause my power steering to not work either. So accelerator pedal position, ABS active, whether ABS is active or not, because that'll affect the steering. RPM, ignition status, that's kind of important to know whether it's on or off. Lane keeping alert requests, so that's for the image processing module A, so that's the camera. It gets a request from the camera. First sent to the gateway module, then the power steering control module. We use the command that gear if intervention is required for the lane keeping alert feature of the lane keep system. So we got to think of how fast the network has to be in this case as well. Power pack status, power system status, stability control, steering angle request, steering effort request, used to inform the current driver selected steering mode, normal, sport, or comfort, steering wheel angle, traction control, brake, trailer backup assist, trailer data, trailer speed limiting status. So yeah, of course, trailers definitely need to know what the trailer is doing. Transfer case range, transmission gear, vehicle configuration information, lateral acceleration, longitudinal acceleration, vehicle speed data, and yaw rate. Like I said, the yaw sensor is needed, plus other acceleration sensors as well. Need to be done for the steering assist calculations. It needs to know how fast it's turning and how far it's turning and all of those sorts of things. So if we go into the actual system itself, it just kind of tells us the functionality of it. Self-monitoring is capable of setting and storing diagnostic trouble codes. Depending on the DTC set, the power steering control module may enter a failure mode. In addition, the power steering control module may send a request to the instrument panel cluster to display a message in the message center alerting the driver of a potential concern. Warning message is sent over high-speed CAN. Anyway, so that is your Ford messages. And then if we go into the scanner, like I said, we go down to steering. We have the power steering control module right there. And in this case, we go into functional tests, special functions. There's a couple different things to reset, like internal failures and things, signal errors. But there's that PMI right there where I have to pull data from the module and then write the data to the new module. So I would read data from I would leave the old rack in the vehicle first, hook up, pull the data off, copies it to the scan tool. Then I put the new rack in and then take that data that's in the scan tool and write it into the new module in order for that to work properly. And then We also need to reset a few things. So where it is in this vehicle dynamics module. Function in there. Well, that's for ride height, so that's for suspension. In the ABS, there's going to be should be the yaw in here. Longitudinal acceleration sensor might need to be done. Yep. So longitudinal accelerations in the ABS, and then sometimes in the airbag we have our yaw sensor. That's just a PMI on that one. Right. Oh, and then our image processing module A, that's for our lane keep. So if we had a problem with the image processing module A, that could cause a steering issue as well with that. So that's our Ford. And we'll take a look at this Infiniti. So we talked about that Q50 with the clutch in the steering shaft. So we'll just go to steering. Oops, spell it right. 2 E's will help. There we go. And funny enough, a lot of TSBs on that. A lot of service campaigns and recalls for this adaptive steering control module. Replace, reprogram, recalibrate. Certain specific hybrids, non-hybrids. It was in there for all of them, I think, right? Helps. Q50 and Q50 hybrid. Let's see. 2 parts to the procedure. Reprogramming includes 3 separate control module reprograms, the DAST1, 2, and 3, and calibration and confirmation procedure. So this needs to be done with like a JBox or the factory tool to flash it. So you basically go in there, you check what software version's on it, VIN and chassis number. You need to verify that too, and then confirm it. And then you would need to reflash the vehicle doing that. So they call it reprogramming, but it's reflashing. And then the part number for that will be there. So just because it didn't work right from the factory, basically. What else do we have? Steering pole and steering wheel off center at PDI. That's a deer delivery. When it first gets delivered off the truck, that's a PDI pre-delivery inspection is what you would have to do. Power steering gear service information. Without direct active steering. So that's a little different. So this one actually uses a pump though. So this is an electric pump. So it gives you the whole linkage, and it's kind of hard to see with the linkage because there is still a linkage there. It's kind of hard to see it though in the pictures they show. Yeah, so there's alignment matching marks on that to go into the rack, and then this is the clutch assembly up here that kind of mounts to the firewall. So it's a little tough to see. Never disassemble. No user serviceable parts inside, I guess. And that's how to do our boots and stuff. Parts for this too. The gear assembly, rack and pinion assembly, it's $1,800, $1,900 for the fancy one. Well, you think that's bad? Wait till we get to the BMW, which uses, it looks like a pretty similar rack to what the Ford uses, and the Ford is way less expensive than the BMW. And then let's go in here under steering again, direct adaptive steering. In this case, we have codes, data, functional tests. I can't pull the functional tests on the simulator though. Have to be hooked up to a car. But you can see all the different codes, communication statuses, steering angles, feedback angles, steering angle sensors, pinion angles, all sorts of angle measurements. There's your side G's for that's your lateral acceleration or yaw sensor would give you that as well. To Electronic power steering is the other part of it. And I don't think that one does. That's for G sensor calibration and steering angle sensor calibrations, and those are basically just zeros. So reset the steering angle value to 0. Function is used to replace the sensor steering column. Straighten the front wheels. Arrange the steering wheel at center. Ignition key off, on, engine off, and continue. And then it'll just do a quick reset. All it does. It's just can't be done because I'm in a simulator. And the same thing with the G sensor. Vehicle on a level surface, and need to have it on a level surface so it's not pitching or yawing in any different directions, and that just basically gives it a level adjustment, which zeroes it out too. And now the BMW. Because if we look at this rack, hit it again. Steering box. There we go. There's TSBs on this one too. There's only one. Steering gear movement not smooth. Unfavorable software of the electronic power steering system. So they did a, and all you get, the only way to fix it is a reflash. And that's why it takes so long, because it programs all the modules. So let's see if I can get some pictures here. It's pretty rough, some of these BMW pictures. But there you go. See, there's the motor, and then it's got the little belt over there. It looks pretty much like the one out of the Ford, but it's $4,500. Turning steering wheel in both limit position. Airbag indicator must not light up in the process. So that's how you know if you screwed up your clock spring. And then you need to teach in the end stops, which is it's a functional test inside the scanner. And then, like I said, the parts, with or without variable steering, $4,500. They're two different part numbers. That's the same part number. One's with or with, and one's without complete. And then initialization 2.6 hours only though. And then to calibrate all this other stuff, adaptive cruise control calibrate, lane departure camera calibrate, steering angle sensor calibrate, tie rod, and then tie rod end replacement. So you got over an hour invested in just calibration on this thing. And if we go in here, and we go down to steering, and we go to electromechanical power steering, and there's 5 different variants, but they all have the same special function. So there's a steering startup function. So for teaching a software end stops, the service function is needed after the following events: this fault code, end stops not taught in, adjusting procedure, repair measures on the front axle, depending on the internal system status, transfer to corresponding startup routine takes place automatically. So steering mounted completely in the vehicle, all connectors inserted, vehicle is on a level surface, warehouse floor or roadway. Alternatively, the vehicle is raised slightly in the vehicle hoist. Steering wheel movement of the front wheels must not be restricted by obstacles. Combustion engine must be running. There must be no internal faults, and must be no internal faults in the ICM control unit at all either. Let's see. They're correctly taught in. So once it's done, don't do it again. Basically what it says, no further measures must be performed. Another teaching process only makes sense if one or more of the following repair works are performed. Adjusting procedure repairs the front axle, especially track rods, steering box was removed and reinstalled. No steering replacement. So you need to teach it in apparently twice if you remove it and install it. And if you just remove it and install it, you have to reset it. So just be aware of that. So that is the long and the short of electronic power steering. It's a shorter class tonight, but that's not a ton to talk about on that. Mainly, it's a scanner reset procedure and relearn. You can see they do require a lot of different inputs, and it can cause problems. Other systems can cause problems with your steering system, so just be aware. So let's talk about what we're going to talk about next week. Pardon me. Next week, we are going back to the beginning of the year with our light duty diesel diagnostics. So if you aren't familiar with how we do things around here, I do 6 classes in a row and then I repeat those 6 classes again. Gives you a couple extra times to catch them live, ask your questions, all that good stuff. So next week will be light duty diesel diagnostics. So every Tuesday, 6 and 9, as always. Go to snapon.com/OT if you want to join us on Zoom. Otherwise, you can join me on YouTube at 6 and then Facebook at 9 Eastern. YouTube.com/Snapon Diagnostics. If you scan that QR code right there, it will automatically bring you to the page and subscribe you. If you want to see any of the other topics in this series, anywhere from intro to ADOS to ADOS specific, OEM specific ADOS training, 108 episodes. This is episode 108 right now. All available for free, about half hour long or so, 40 minutes depending on the topic, and everything in between. So yeah, check that out. They're all free. Free diagnostic training. Gotta love it. And do we have your email address? Because if we don't have your email address, you may be missing out on some things like technical focus articles, SureTrack blogs, quick tips, new product releases. If you scan that QR code right there, it'll bring you to a page where you can put in your information and you can start getting this valuable information in your email. It's not going to spam you with a million emails a day or anything like that. It's maybe a couple a month. They send out my schedule periodically too. Here's an example of a tech focus article on timing chains, stretching. So all sorts of good information. So definitely make sure you plug in your email address. All right, time for questions. But before we do, I want to make sure I mention my buddy Keith, who also does training for free every Wednesday and Thursday. So Wednesday is on Zeus Plus, Thursday is on Triton and Apollo Tools. And he goes everything from soup to nuts, all the way from setting up your Wi-Fi, talk about security link, talk about Snap-on Cloud, go through everything on Fast Track Intelligent Diagnostics, talk about the scanner and how it works. All sorts of good stuff there. So every Wednesday and Thursday, Zoom only. It's meant to kind of have the tool in front of you while you watch what he does on his screen. You can do what he's doing on your screen and follow along. So definitely worth your time. Go sign up for that. All right, let's go to questions. So we're clear on Zoom right now. If you do have a question on Zoom, just use that Q&A button. On YouTube, we got a couple. Let's see. Quick Automotive Diagnostics says, hello, have you ever experienced Zeus Plus screen flickering on camera when filming the screen? Yes. It happens all the time because of the type of screen that it is. So iPhones and DSLRs and things like that have that rolling shutter effect that they do because of the type of screen, because it's different than the older Zeus, which didn't do that. I don't remember which way it is. It's LED or IPS or something like that. There's a difference where if you film certain screens with any non-professional camera and you can't change the shutter speed on the camera, then it'll do that. It gives you like the jelly screen. So yeah, it happens all the time. It frustrates the film crew to no end either, but they have adjustments on their camera to do it. So have seen that. So thanks for that question. I'm guessing you've probably been trying to film some videos with it. So let's see. Nick says hello from the UK, 11 o'clock at night. It says hello to Keith as well. Ray in the Bay. Let's see. Stinnet's Body Shop asks, why does a Tesla Cybertruck rack use 2 electric motors? Not really sure. Maybe they just have one for left and one for right, I suppose. Could be. Seems like some of this stuff tends to be a little overcomplicated for some of the things that they do. So I'm not really sure why they decided to do that. Curtis Connolly says, hello from West Texas. Hello, Curtis. And Nick can't wait for next week's training. And let's see. Thanks for all the instruction. Paolo asked, thanks for all the instruction. Do I need both Windows 11 on one laptop and Windows 10 on another, since I work on all makes and models once I start programming? So as of right now, it may have changed since the last time I did a flashing class, but as of right now, not all manufacturers are on Windows 11, if any are. I'm sure they must have started transitioning by now because Windows 10 is going out of update in a little while. But you would need to do one of each if one manufacturer does require 11 and one requires 10. because you just can't get around those requirements at all. They won't install the software if it's not the right operating system. So you may have to, depending on what the manufacturer's specs are right now. You do have to do different. Let's see. Anonymous on Zoom asks, "What do we use for an OBD simulator?" So this is actually just built-in software that allows us to simulate any car on our software, so we can see, for tech support purposes and things like that. So we can see what the different menus are on our software. So it's just custom software that we make for that purpose for us, because it does some weird wonky things. So you wouldn't want to necessarily take it as gospel, because sometimes it, like for example, it doesn't show all the functional tests in there sometimes, depending on the vehicle. So yeah, but it is just our own custom software that we put on it. All right, so that is question. I'd like to thank you. Thank you very much for spending a little bit of time with me. Hopefully you learned a couple little tidbits on electronic power steering. Hopefully you'll join me next week for diesel class. And with that, enjoy the rest of your week. Enjoy your weekend. Have a nice night and take care.